Name of the experiment is conductometric estimation of acid mixture using standard sodium hydroxide solution. Aim of the experiment is determination of weight and concentration of HCl and acetic acid present in the acid mixture using standard sodium hydroxide solution and whose concentration is 1 normal. And for this experiment we need these reagents, that is acid mixture, HCl and acetic acid, standard sodium hydroxide, and the apparatus required for this experiment are 10 ml microburette and then conductivity meter with conductivity cell. Using this conductivity cell, it is connected to conductivity meter and it is dipped in water. Next is calibration of instrument. So, we have to calibrate the instrument by turning this mode knob to temperature, and we have to set the temperature using the temperature knob to 25 degree centigrade, and then turn this mode knob to conductance at 25 degree centigrade. Then we have to measure the conductance of the solution. We have to wash the burette well with water. After washing the burette well with water, then we have to fill this burette with sodium hydroxide solution, standard sodium hydroxide solution. Before filling the burette with standard sodium hydroxide solution, we have to transfer little amount of standard sodium hydroxide solution, rinse the burette. This rinsing is done to avoid the dilution of given solution. Throw the rinsed solution into the sink, then fill the burette with given standard sodium hydroxide solution. And here adjust the level to the lower meniscus. Since the solution what we have taken is colorless, therefore we have to adjust to 0 by considering the lower meniscus. Now clamp this to the stand, then take one empty beaker, transfer exactly 50 ml of acid mixture into the beaker. Transfer 50 ml, and now we have to transfer this washed electrode into the acid mixture. Then we have to note down the initial reading what it is showing. After this, we have to add 0.5 ml of this solution into the beaker. Add 0.5 ml. Here we have to consider the lower meniscus. After adding 0.5 ml of sodium hydroxide, mix the solution slowly with the help of conductivity cell and then note down the conductance of this solution. Conductance depends on the mobility of ions and also the number of H plus and OH minus ions present in this solution. Then continue the same thing. After every addition of 0.5 ml, we have to mix the solution and we have to note down the conductance. Add 0.5, then mix the solution and note down the conductance. See, conductance is decreasing. So, this is continued till the conductance value decreases slowly and then rises slowly, then rises steeply. Until that we have to continue the titration. Then all the readings we have to tabulate in the tabular column. Then we have to plot the graph and then we have to do the calculation part. So, this is one sample record. After writing all the readings in the tabular column, then we have to draw the graph first. See, this is the sample graph. Here we have to take conductance along y axis and volume of NaOH along x axis. First we have to draw first line. For the first mark the points on the graph, then draw first line on decreasing points, then we have to draw the second line on slight increasing points. Third line is drawn for steep increasing points. We have to draw the line on maximum number of points here. Then we have to write the scale. First first here we are taking V1 value. V1 value is nothing but it is the intersection of first and second line. First and second line intersection V1 value gives you the volume of NaOH required to neutralize the strong acid present in the acid mixture, that is HCl. Here the value is 2.1. 2.1 ml of sodium hydroxide is required to neutralize taken HCl solution. And then one more intersection line is there here. The second and third line intersection value, that is 5.2. This value gives you the amount of HCl required to neutralize both, that is HCl as well as acetic acid. So if you want the volume of NaOH required to neutralize only the acetic acid, we have to subtract this V1 value from V2 value. Then we have to calculate the normality of HCl. To calculate the normality of HCl, we are using this equation, and after calculating the normality of HCl, we have to calculate the weight of HCl present in 1 liter. After calculating this weight of HCl present in 1 liter, then we have to estimate acetic acid also. To estimate the acetic acid, first we have to calculate the volume of NaOH required to neutralize acetic acid, that is V2 minus V1. Here the normality of acetic acid is calculated using this equation. After calculating the normality of acetic acid, then weight of acetic acid is calculated using normality of acetic acid and equivalent weight of acetic acid. Finally, we get the weight of acetic acid present in 1 liter. In this experiment, we are going to find the weight of HCl present in 1 liter as well as the weight of acetic acid present in 1 liter. And finally, we have to write the readings here, that is the result at the end. And the writing record is, first we have to write the aim, principle, procedure, right hand side, and observation calculation part on the left hand side. Then we have to, after plotting the graph, we have to stick the graph here. Finally, we have to show the result, that is weight of HCl present in 1 dm cube or 1 liter, that is in terms of grams per liter, and weight of acetic acid present in 1 liter in terms of grams. In this experiment, the possible viva questions are: what is meant by conductance, what type of conductance is measured, what are the different conductance we are going to measure, and here what is the intersection of first and second line indicates, what is the volume of NaOH corresponding to the intersection of second and third line, and why conductance decreases in the beginning, and then why conductance slightly increases, then why it increases steeply. The conductance in the beginning decreases because decrease of H plus ions, and slight increase in the conductance is due to the increase of, that is electrolyte sodium acetate, and steep increase in the conductance is due to the increase of OH minus ions. Here the conductance depends on the mobility and number of H plus and OH minus ions.